Hello students, welcome to my class. Today I am going to discuss about few questions related to NEET, related to state of matters. That is, in state of matters we have discussed about different laws, gas laws, like do you remember this friend? Boyle's law, Charles law, Gay-Lussac's law, Avogadro's law, pressure temperature law, then temperature, boil temperature, critical temperature, lots of things we have discussed about discussed in state of matter. So today we will discuss few questions, how questions are asked from this topic from a state of matters. Clear to you friend? So let's start with the topic. That is, my first question is, look at what I'm telling, listen carefully, wait for a moment. The question: a closed flask contain water in all its three states, that is solid, liquid and vapor at 0 degrees Celsius. Clear to you? In this situation, the average kinetic energy of the water molecules will be, what is telling? That is about the average kinetic energy. Clear to you? As we people know, listen carefully, if I talk about solid, if I talk about liquid and if I talk about gaseous molecules, we all know in solid the particles are very close to each other. Do you remember this? If there is a very closeness between the particles, then we can say there is high intermolecular force of interaction. High intermolecular forces. Clear? If there is a high intermolecular forces, then there is very less randomness. That is, there is no movement, very less movement. If there is very less movement, then what will happen? The kinetic, the velocity decreases. If velocity is decreases, or if velocity is very less, then what will happen? As we know, kinetic energy is equal to what will? Half mv square. Do you remember this? That is, kinetic energy is proportional, that is related to the velocity. If velocity decreases, if there is very less quantity of velocity, then what will happen? Ultimately the kinetic energy decreases. Is it clear to you? Now listen what I am telling again. If I talk about the liquid molecules, as we know, in liquid molecules there is a little gap more than the solid molecules. If there is a gap, that means to say there is very less intermolecular force of attraction in comparison to solid. If there is very less more intermolecular force of interaction, then what will happen? There is a movement, then the randomness will increase. If randomness will increase, then ultimately what will happen? Velocity will increase. Am I right or wrong? If velocity increase, then definitely kinetic energy will increase. So if we compare the average kinetic energy between solid and liquid, then what will happen? Liquid will have more amount of kinetic energy in comparison to solid. Now if I talk about gas, as we people know, there is a very less intermolecular force of interaction between the gaseous particle. If there is very less intermolecular force of interaction between the particle, then what will happen? There is an increment in randomness, that is particle move here and there. If there is an increment in randomness, then what will happen? There is an increment in velocity. If there is an increment in velocity, as we people know, kinetic energy is directly linked to the velocity, so definitely the kinetic energy increases. So in this case, now tell me which will have high value of average kinetic energy or kinetic energy? The greatest in all the three states? No, this is wrong. The greatest in vapor state, that is the gaseous state. If I talk about water, water has solid state, liquid state and vapor state. The greatest in the liquid state? No. The greatest in the solid state? No. So this is the actual answer, B option, the greatest in the vapor state, because in vapor there is very less intermolecular force of interaction. If there is very less intermolecular force of interaction, then we can easily say the randomness increases. If randomness increases, that is the movement increases. If movement increases, that is in terms of velocity, velocity increases. If velocity increases, ultimately what will happen? Average kinetic energy increases. That is in terms of randomness, that is the definition in terms of what? Velocity. I am not going to discuss this question in terms of temperature. Do you remember this formula? Kinetic energy of 3 by 2 kT. This K is Boltzmann constant, because here is mentioned the temperature here not changed, so there is no impact of temperature in this case. So in this case I am applying the formula kinetic energy is equal to half mv square in terms of velocity. So be careful be careful while using formula, because according to the situation the formula changes, because kinetic energy has more than one formula, that is 3 by 2 kT and k is equal to half mv square. Clear to you, friend? So now I am going to rub this part and will discuss the next one. Wait for a moment. If you have any doubt regarding the question, you can easily approach to me. This is NEET special. Now look at, as I told you earlier, the question is the root mean square speed at STP. What is STP? Tell me. This is standard temperature and pressure. Do you remember? There is two types, STP and NTP. NTP, that is normal temperature and pressure. If temperature is 0 degrees Celsius, then generally STP. If temperature is 25 degrees Celsius or 27 degrees Celsius, that is NTP, normal temperature and pressure. What the question says? The root mean square speed at STP for the gases H2, N2, O2 and HBr are in the order. Now question, that is root mean square speed. Do you remember what is the formula of root mean square speed? Yes sir, that is root mean square speed equal to, tell me the formula. Do you remember this? That is root under 3 RT upon m. Clear, friend? That is root under 3 RT upon. If anyone asks you what about the formula of most probable speed, then tell me, sir, the formula of most probable speed is equal to root 2 RT upon m. If anyone asks you what is the formula of average speed, then what will happen? So the formula of average speed is equal to root under 8 RT upon pi m. Am I right or wrong? So wait for a moment. Sir, you are absolutely right. Now here the root mean square speed. Look at the formula. Here root under 3 RT upon m. Here the temperature STP fixed, and as we know R is also fixed. This is gas constant. That what we can say, that is here the variation root mean with, we have to check the value of m, that is molar mass. That is, it is inversely proportional. If molar mass increases, then root mean square speed decreases. If molar mass decreases, then root mean square speed increases. Clear to you? Now tell me which molecule have high molecular mass. If high molecular mass, then what will happen? Then it will have less value of root mean square velocity. If I talk about HBr, as we know hydrogen and atomic mass 1 and bromine around 80.5, that is around 81.5. Clear to you? If I talk about nitrogen, it has molecular mass 28, and if I talk about oxygen, it has molecular mass 32, and if I talk about hydrogen, it has molecular mass 2. Now tell me which one will have low molecular mass? Hydrogen. So it will have high value of root mean square speed. So the order is HBr, high molecular mass, less order. Then there comes oxygen, then nitrogen, then hydrogen. What is the order? Check out H2, N2, O2 and HBr. This one is incorrect. HBr, then O2, then N2, then H2. This is the correct order. Clear to you, friend? I think you you can easily understand, you can easily solve such questions if you have a strong basic concept regarding to state of matter. Clear, friend? Now I'm going to rub this part and we'll discuss the next one. Wait for a moment. By using this question, we are also revising the chapter. Clear to you, friend? Now let's move to the question number 3. What will happen in this case? Let's check it out. In a closed flask of 5 liter, 1 gram of H2 is heated from 300 to 600 Kelvin. Clear to you? That is, if I write here T1 is 300 Kelvin. Clear to you? Now here T2 is 600 Kelvin. Clear to you, friend? That is, temperature increases from T1 to T2. Clear? But mass and volume remain same. If mass and volume remain same, then definitely we people know there is no increment in the number of moles. It is fixed. Clear, friend? So we can say in this case, no increase in number of moles. This is fixed to you. Okay, this is the first concept. Now, if temperature increases, then definitely with rise in temperature that the randomness increases. Randomness increases, that means to say velocity increases. Velocity increases, that the average kinetic energy increases. Then definitely if kinetic energy randomness increases, there is the number of collision increases, which ultimately lead to the increment in pressure. Am I right or wrong? So you are absolutely right. What I am telling, listen carefully. If temperature increases, then definitely the randomness increases. If randomness increases, that means to what it says? That means to say the velocity increases. If velocity increases, definitely the kinetic energy, that means to say the energy increases. And if randomness increases, that particle will move here and there, and due to this reason there is a collision between the particle, that is the number of collision also increases. If number of collision increases, ultimately what will happen? The pressure of the system will also increase. So in this case what will happen? Pressure of the gas increase, rate of collision increase, the number of mole of the gas increase. No, in this case the number of mole of the gas is not increases, because there is fixed volume and fixed mass. So no increment. The energy of the gas, yes, 3 is correct, but this one is incorrect. Clear, friend? Now what is the question? Which statement is not correct? So this statement is not correct. So the option is C. C is the correct option. Now rub this all the things. So now you can easily say, sir, C is the option. Am I right or wrong? Sir, this is correct. You are absolutely right. Now I am going to rub this part, friend, and now moving to the next one. The next one is this one. Pressure, that is, the question is pressure remaining same, the volume of a given mass of an ideal gas increases for every degree centigrade rise in temperature by definite fraction of its volume at. We people know this is the complete statement of Charles' law, that is per degree rise in temperature, that is volume 1 upon 273.15 at 0 degree Celsius. Clear to you? This is the statement, simple statement of Charles' law. So the answer in this case 0 degree. This is a simple question, you can easily solve. This is a question from PMT, previous year PMT questions. Clear, friend? Now let's move to the next question. Now look at, this is a question, this is a good question, and this question is from 2018, this year 2018 NEET examination. Look at what as we know here given the value of van der Waals constant A. As we know there are two van der Waals constant A and B. Do you remember this? And A signifies the intermolecular force of attraction. We people know this. Now question, read the question. The value of van der Waals constant A for the gases O2, N2, NH3 and CH4 are 1.360, 1.390, 4.170 and 2.253 liter square atm per mole square. Respect the gas which can most easily be liquefied. liquefaction of gas? As we know, A signifies the intermolecular force of interaction. That is, higher the value of A, higher is the intermolecular force of attraction. Clear to you? If the intermolecular force of attraction increases, then what will happen? The gas will be converted to solid. Gas will be converted to liquid. Liquid will be converted to solid. This is the case. So in this case, these all are in the gaseous form. Now the question, the gas which can most easily be liquefied, that is ease of liquefaction, that is the conversion of gas into liquid. In which cases, in terms of A, as we know, higher the value of A, higher is the intermolecular force. If particles comes closer, then what will happen? The state changes, gases will be converted to liquid. So in this case, check out which one has high value of A, that is high intermolecular force of attraction. In case of, if I watch, that is O2, N2, NH3 and CH4, we watch that NH3 has high value of A, that is it has high value of intermolecular force of attraction. Am I right or wrong? So you are absolutely right. So if it will have high value of intermolecular force of attraction, then we people say the ease of liquefaction is more in case of NH3. So tell me which option is correct? So the C option is correct. Clear to? This is a complete theory based question. If you have, again I am repeating, if you have a strong theory related to any chapter, then you can easily solve such type of questions. Clear to you, friend? I have given various questions from previous years and also from different part of this chapter, so that you can easily understand the topic, so that you can easily solve the previous year question, easily solve the competitive level type questions. Clear to you, friend? Now I am moving to the next part. Look at this question. What is given? The given graph represent compressibility factor, that is Z is equal to PV upon nRT versus P. This is the graph between Z and P. Clear to you, friend? For three real gases A, B and C. This is the gas A, this is gas B and this is gas C. Clear to you? Identify the only incorrect statement. Have you seen the graph? Look at. We'll move to the next slide for the option. Look at here. This is the gas A, that is the slope increment. Here the slope decreasing, and there's this one is a variation in slope, that is from negative side to moving towards the positive side. Clear to you? Now what is the question? For the gas A is equal to 0 and a dependence of P is linear at all pressure. Yes, definitely it is linear at all pressure, because here is the positive slope, it will linear at all pressure. Clear? Now next option, for the gas B, what I am telling, listen carefully. For the gas B, B is equal to 0, the second van der Waals constant, and its dependence on pressure is linear at all pressure. Now check it out. I am moving here. This is the B at all pressure. As we know, if pressure increases, then the graph moves from negative to positive side. But if we look at this graph, there is a negative slope. It is not moving from negative to positive side. Clear to you? Do you remember this? That is, at all pressure linear is all okay, but if pressure increases, that means to say that is the slope will changes from negative to positive. In this case, look at, the slope is negative. If it is treated as, this line is treated as the baseline for, and this baseline is the ideal gas, and these all are the real gas. If this is a baseline, here the positive slope, but here the negative slope, but at here the in the question, that is at all pressure, that is linear at all pressure. Not possible. If pressure increases, the slope will move from negative to positive. So what we think, this option is not correct. But for the gas C, check out the another option. This is the graph of C. Now look at, for the gas C, which is a typical real gas, for which neither A nor B neither A nor B equal to 0. By knowing the minima and the point of intersection with Z equal to 1, A and B calculate. Definitely for this graph we can easily calculate A and B if you know the minima. Next one, at high pressure the slope is positive for all real gas. Definitely at high pressure the slope is always positive, because here the contradiction, look at. So here in this case, look at the actually this question has its answer also, because in 4 at high pressure the slope is positive for all real gas, definitely. But if I talk about B, it is what it is telling, that is at a dependence on P and is linear at all pressure. Here the graph is slope is negative, but the question saying last option, that is at high pressure the slope will be positive but it is negative. So that means to say here is the answer. So this question says I have an answer. Check all the option, you will find the answer. Clear to you, friend? Wait for a moment. So for this case we can say B is the correct option. Clear, friend? Now I am going to rub this part and we'll discuss the next one. Positive deviation from ideal behavior take place because of. As we know, if Z is greater than 1, this is the positive deviation. If Z is less than 1, then it is the negative deviation. And we all people know Z is equal to PV upon RT for 1 mole of a gas, and Z is equal to PV upon nRT, clear to you, for n mole of a gas. Am I right or wrong? So you are absolutely right. For n mole of a gas, for positive deviation, that is PV upon nRT is greater than 1. So in this case we can say, sir, this one or this one may be correct, because this one is less than, this one is less than. So we can eliminate B and D option. Now focus on A and C. Look at here. In this case deviation, what we judge? The molecular interaction. Clear to, not size. So molecular interaction between atom and PV upon nRT greater than 1. So when we compare B and A and C, then what will happen? This is option correct, and here is the molecular interaction, because in ideal gas behavior, ideal from real, there is a main things, first of all molecular interaction. So the case is A, molecular interaction between atom and PB upon nRT greater than 1. So remove all the things. Now tell me which option is correct. Sir, A option is correct. Clear to you? If you have any doubt, you can easily approach to me. Now wait for a moment. Now let's move to the question number 8. Now look at, this is a graphical question. Read the question carefully. Which of the following volume temperature plot represent the behavior of 1 mole of an ideal gas at the atmospheric pressure? Clear? As we know, graph between V upon T, clear to you? That is V upon T, formula V1 upon T1 is equal to V2 upon V2 upon T2. Do you remember this? That means to say V upon T is equal to constant. That is, we can say that is V is directly proportional to T. At every stage V upon T is equal to constant. That is the case. Here the graph. Now according to the question, which of the following volume temperature plot represent the behavior of 1 mole of an ideal gas at atmospheric pressure? First of all, check it out. At 1 atm and 273 Kelvin, that is 0 degree Celsius, the volume of a gas is 22.4 liter. According to the theory, is it correct? Yes, sir, it is correct. So look at the C and D. Volume is 24.4 and here is 22.4. Clear to you? If I talk about this graph, this one is incorrect. It cannot be, because according to the question here should be volume 22.4 liter. So we will eliminate this option. Now check out this. This C will not be the answer. Now if I talk about D, look at here, the slope is downward. As we know, V is directly proportional to T. If T increases, ultimately V will increase. If V will increase, ultimately that symbolize that the temperature increases. So here the negative slope, the negative decrement, so this will not be the option. Clear? Now if I talk about A and B, we people know, when we, do you remember this, when we draw the graph of V and T, this is the slope and this is, tell me, absolute zero temperature. Do you remember this? minus 273.15. Clear to you? This is absolute, that is the directly proportional slope, positive slope. This is the graph. Now we can also draw the graph like this also. Okay, now look at this one, and this one is correct. Why this one is not correct? I have discussed this. Now how to eliminate the last option? Now as I told you, V upon T is constant. If I compare here, this one is V1 22.4 liter and T1 is 273 Kelvin. Clear to you? Now put here V1 upon T1, and in this case V2 is equal to, tell me, 38.8 liter and T2 is equal to 373 Kelvin. Now what we find in case of A, V1 upon T1 is not equal to V2 upon T2. Clear to you? Wait for a moment. What I am telling, not equal to, that is, this is not a Charles law. But if I use the option of B, then what will happen? Look at here, V1 is equal to 22.4 liter and T1 is equal to 273 Kelvin. Clear to you? Now V2 is equal to V2 is equal to 30.6 liter. Clear to you? And T2 is equal to 373 Kelvin. Now check out the things. If I put here V1 upon T1 equal to and V2 upon T2, if I solve, V1 upon T1 and V2 upon T2 will get the exact value, that is around 0.082, which signifies that this graph completely represent the V by T graph, and this is known as Charles law. We people know this. So how to eliminate? This will not be correct, because in this case what will happen, at 273 Kelvin the volume should be 22.4 liter. So this will be the not option. Now eliminate this. Now what will happen in this case? There is a negative slope decrement, so it cannot, because V is directly proportional to T, not inversely proportional. So this will not be the option. Now if I compare, this one is a perfect graph, but if I compare A and B option, then what will happen? In case of A, V1 upon T1 is not equal to V2 upon T2. If V1 upon T1 is not equal to V2 upon T2, then this is the not the graph of V by T. But here V1 upon T1 is equal to V2 upon T2. So this is the option. So before solving the question, check out all the option. Actually what happens, the options gives us clue to solve the question. Sometimes we do not read the question carefully. That is the problem. Students should focus on the questions. If he or she study the question carefully, then definitely he or she will get the answer. Clear, friend? So for this, that is the option B is correct. Now I am going to rub this part and moving to the next question. Now the next question is, the compressibility factor of a gas is less than unity at STP. That is, compressibility factor Z is less than 1. We all know Z is equal to Vm upon V idle. Now here is less than 1. As we know, at STP V idle is equal to, friend, 22.4 4 liter. Clear to you? Put this value, then what will happen? Vm is less than 22.4. This is a straightforward question. The compressibility factor, that is the value of Z of a gas, is less than unity, that is Z is less than 1. Am I right or wrong? Sir, you are absolutely right. Z is less than 1, that is Vm upon Vid, which is the value of Z in other form, and other form of Z is equal to PV upon nRT also. Here Vm upon Vid. Clear to you? Now Vid at 20, the ideal gas volume of the ideal gas at STP, as I discussed earlier, that is the volume should be 22.4 liter. Put this value here, then what will happen? Vm is less than 22.4. So in this case the option B is correct. Clear, friend? Now I am going to rub this part and will discuss the next part of the question. Now let's move to the question number 10. What will happen? According to the kinetic theory of gases, for a diatomic molecule, what I am telling, according to the kinetic theory of gases, as we all know, according to the kinetic theory of gases, K is equal to 3 by 2 kT. T is temperature, K is, tell me friend, K is, tell me, it's your turn, what is K? I am giving you a chance, tell me friend, what is the value of K? So K is Boltzmann constant. What is? K is Boltzmann constant, that is R upon Na is equal to K. Do you remember this? R is gas constant and Na is Avogadro number and K is Boltzmann constant. So kinetic energy is average kinetic energy, or you can say mean translatory kinetic energy, is equal to 3 by 2 kT. It is symbolized as 3 by 2 kBT. B for Boltzmann. Clear? Now the pressure exerted by the gas is proportional to the mean velocity. Now here look at, that is K is equal to, we people know, half mv square, that is mass, or you can say directly proportional to temperature. There is no involvement of what I am telling friend, there is no involvement of pressure. So check out where there is a translative, that is the mean translational kinetic energy of the molecule is proportional to the absolute temperature. The mean translational kinetic energy of the molecule is proportional to the absolute temperature. Clear to you? This is the expression. Clear? If you have any doubt, you can easily approach to me. This is the option D. Clear, friend? Tell me, am I right or wrong? Sir, you are absolutely right. This is a simple question. You can easily, completely theory based question. So if you solve such type of question, then definitely it will boost your knowledge, and this is completely based on NEET pattern. If you want more questions from my side, then you can easily approach to me. You can directly ask to me. I am always here to help you, to serve you. Clear to you, friend? So this is the last question of today's lecture. We will meet again. Thank you so much. Bye bye.